Good morning, good afternoon, good evening. Welcome to this IFS webinar. Today's title is Optimizing Assets for Renewable Energy. My name is Bas Beemsterboer. I'm the Global Asset Management Evangelist at IFS. At the renewables industry, we've identified a number of challenges that customers are facing, ranging from market challenges to asset-based challenges, financial challenges, and societal challenges. Deloitte summarizes it nicely in their Power and Utilities Industry Outlook, where they say that the tough challenges are boosting clean energy, ensuring reliability and resiliency, and maintaining security while keeping the cost down. If I translate this to asset management and asset lifecycle management. The words that spring out are decarbonization, digitalization, and decentralization. And the conclusion is that industry spending will remain high and renewable penetration could accelerate further. This is music to our ears at IFS because we specialize in asset management in the utilities industries, and specifically in renewables, and how the asset is expressed in the full life cycle. So let's dive into that. When you see that over the past decade, the cost of energy has dramatically been reducing, especially for renewable sources like solar and wind. And basically they've become up to par with, let's say, traditional fuels. And at the same time, the society mandates, through net zero initiatives, Paris Agreement, and what have you, to invest in geothermal, offshore wind, onshore wind, and solar. There's a clear case that investments are, massive investments, I would say, are bound to happen. For that, we need to optimize our asset life cycle in terms of capital expenditure, operational expenditure, to increase reliability, resiliency, and asset utilization, as Deloitte stated in the previous slide. And we need to look at how we can digitally transform our operations. So talking about asset life cycle management, what we find key at IFS is to, when we talk about assets, to talk about the complete life of the asset, starting from the inception and design all the way to the decommissioning. The Institute of Asset Management has worded it as follows. Asset management requires an integration of activities across the whole life cycle, not just individual life cycle stages, and especially focused on the design phase of the asset, which determines in the end, more than 80% of the total life cycle cost, as well as the environmental impact, which means that if we don't cover the initial stages of the asset life cycle, we miss out on all the optimization capabilities and possibilities later on. So let's take a look at this first three stages of the asset in its life: the design, the build, and the commission. Basically, for many customers, organizations, this is specified as the project performance phase of the asset, which means we need to offer capability to manage shipping and commissioning, handover, fabrication, design, commissioning, all those stages that happen before we start to operate our asset. The definition of project performance management, as stated on the left-hand side of this slide, is to create, manage, and implement projects that contribute to the performance of an organization, and not really only focusing on task execution. Project performance is about the bigger picture. So when we take this one step further and talk about the asset lifecycle stages, that means operate and maintain, the optimization and decommissioning in the end. There's, of course, the traditional asset management activities like reactive, preventive, condition-based, reliability, and predictive or even prescriptive maintenance, which is the activities that are typically associated with an asset management application or platform. There's also, of course, during the life, room for improvement, for new asset planning, for asset operations, reliability, and what have you. So asset performance management is the approach to managing assets that prioritizes business objectives, in addition to traditional reliability and availability goals. And therefore, asset performance management has become an enabler for digital transformation in the asset space. Now, if we combine these two concepts, you can see how they work together. Projects and assets, it's all about the assets, and IFS is uniquely able to combine the project performance and the asset performance in one platform. So now we take this a more detailed look so that you can clearly see this revolving wheels or feedback loop, if you will, where the asset life stages start at inception, design, construction, fabrication, acquisition, what have you, all the way to the life stages where we apply the traditional asset management capabilities, all the way to improvement and potentially to sending it back to the project stage for refurbishment, renovation, overhauls, modification, shutdowns, and ultimately at the life end of the asset decommissioning, or in case of circular economy, to the disassembly and creating new assets from the scrap parts. So this is a feedback loop that basically goes endlessly, revolves endlessly, in the IFS platform. So now let's take a closer look at the asset lifecycle stages and how the asset management maturity plays a role. So first of all, you see the design, build, commission, and then operate, and maintain, optimize, and decommission stages that we mentioned earlier, which are underpinned by superb capability in the IFS platform to manage all of that shown in the wheels, while optimizing all the resources that are needed at any stage in the asset life cycle, ranging from contractors, spare parts, vendors, employees, etc. But inside that, we see companies mature from a reactive-based, or if we call it maintenance 1.0 approach, fix it when it breaks, through preventative routines, through condition-based maintenance, all the way to what is now regarded as world standard maintenance 4.0 processes, which is basically expressed as predictive maintenance algorithms assisted by artificial intelligence and assisted by machine learning in order to improve and provide true asset performance. In the IFS platform, we'd like to take this one step further. We call this last step in the maturity curve, optimized asset performance management. Let's have a closer look at what that means for us. Typically, let's imagine that you're owning an asset base of, let's say, utility assets. Let's say that this is a transformer. And the transformer is digitally enabled to sense the operation, of course, from energy consumption to vibration to all kinds of performance measures that can be digitally sensed and sent to the IFS platform. The artificial intelligence will kick in, and based on reliability settings, based on resource availability, will determine who should perform a, let's say, preventative task. Why should that be performed? Based on which criticality and urgency should that be done? What should actually be done and prescribed? When should it be done? And potentially where should it be done if it's a mobile asset? Then, the task can be further, enhanced by scheduling the repair in addition to a generation or an outage or a production schedule based on parameters that you wouldn't manage, and potentially, replacement assets, replacement spare parts, maybe even contractor resources need to be ordered. All of these processes up to this point can be automated without any user interaction. Only now, the engineer is sent on site to go and take a look at, and not only to go and take a look at the transformer, but actually with a prescription of exactly what needs to be done in order to prevent the failure from happening. This, of course, greatly enhances the efficiency of the operations, but also makes sure that the asset will continue to operate, to its full length and to its full capacity without any interruption that are not planned or scheduled. Ultimately, through the prescriptive work, after the engineer is done with his corrections, the transformer is put back into operations, or remains operations if it was an on-condition prescriptive job, and disasters is averted, as you can see here. So this is how artificial intelligence and machine learning, together with the foundational elements and capabilities of IFS Cloud, will make sure that the right maintenance is done at the right time, nothing is under-maintained and nothing is over-maintained. The exact right and efficient processes have been scheduled by the APM engine and executed by the engineer. So the resource optimization phase is the uniqueness of IFS that applies, the scheduling optimization engine to make sure that the work is scheduled in accordance with all the constraints that are relevant for this operation. So back to our maturity curve. Let's see how we can align, because one thing is to be able to execute asset management processes and optimizing along the maturity journey or the maturity curve. The next step would be to see how we can align these same activities in the same platform to companies' larger or greater strategic objectives. Typically, when we talk about asset management and asset management strategies, we talk about value drivers such as asset utilization improvement, cost optimization, capital use, compliance and sustainability, often nowadays described as ESG, and digital transformation. Just a sample of the capabilities and functionalities that are available in IFS Cloud to underpin these value drivers, ranging from reliability on the left-hand side. You see RCM and OEE, reliability-centered maintenance and operational equipment effectiveness, overall equipment effectiveness, through cost optimization, capital allocation, which is a typical application of projects, but also inventory optimizations for your net working capital, and planning out investments in the future. Compliance and ESG can mean many things to many people. There's even a new paradigm being defined called Industry 5.0, which is human-centric, resiliency-centric, and sustainability-centric maintenance management through digital transformation. Ultimately, what all these value drivers contribute to is the, let's say, the C-level strategic objectives of increasing revenue, or maybe in case of a downturn in the economy, improving margin, optimizing capital spent today and in the future, reducing the CO2 footprint so that we're all working towards net zero emissions in 2030 and 2050, and boosting productivity. Now let's have a closer look at the actual application. I have a short demo of each of these points. So let's talk about asset utilization. Asset utilization and reliability increase require capability to execute, capability to define reliability, and ultimately to bring us up to this path or journey to asset performance management. And for asset performance management, we need to be able to ingest data from external resources, like the sensors on the transformer that we just talked about. So an IoT controller overview inside IFS Cloud will give us machine status, will give us measurements, and will give us events that have been generated, in this case for a wind turbine cell. And of course, not only do we ingest measurements, we also derive from those measurements alarms and faults that may occur or have occurred. As we saw in the previous picture, we do not only want to be reporting on when actual faults have occurred, but we actually want to prevent them from happening by applying the artificial intelligence and machine learning capabilities of IFS Cloud to the ingested data, combining that with transactional data that is stored in the work order history and in the logistics history, to make sure that we can provide these, based on the machine learning models inside the application, the alarms and the prescriptive maintenance that we desire to have in the hands of our technicians. So that in the end, we can visualize the asset health, we can predict the deterioration of asset health, and we can act through prescriptive work orders in order to prevent failures from happening. So you see some summary on the left-hand side, prescriptive maintenance analytics that focus on the insights that are coming from the sensors. Of course, not only IoT sensors are enabled, also more traditional sources like SCADA or DCS systems will provide the data and the measurements, the observations that are necessary to execute and to create prescriptive orders. So we get an asset health indication, we use historical data, including IoT, we forecast future readings for the sensors, we combine that into the machine learning models so that we can view anomalies and forecast future anomalies, and then view the performed work tasks as they have happened or as they are supposed to happen. So that was a quick view into the asset utilization capabilities and the, let's say, coming from APM inside IFS Cloud. Let's take another look at projects. We talked about assets and we talked about projects. So let's have a deeper look in, let's say, some functionality around projects. One of the key points in the IFS Cloud is how the two wheels, remember, the project performance wheel and the asset performance wheel, interact. And this interaction is unique in the world of EAM as we see it. That means that we have to be able, of course, to create projects, to schedule projects, to create work breakdown structures with nice and good, interesting visualizations in Gantt charts, for example, to defining components that are part of the work breakdown structure and basically to predefine, if you will, from project deliverables, an entire equipment hierarchy, in this case of a wind farm, the design of the materials, to manage the design of the assets, the spare parts, the shipment, the installation, the fabrication, the acquisition. All of those activities are part of the project still, all the way until we execute the project with work orders. And when the project is finished, we can copy all the elements directly to the live situation or the live stages of the asset hierarchy so that we can transfer them to maintenance in order to start operating, obviously, and maintaining whenever it's needed. So we end of an asset in the asset screen of IFS Cloud. So having seen a quick introduction to APM and assets and projects and the link between the project stages and the asset stages of the asset, let's move to the last block here on this slide, which is digital transformation. Digital transformation means many things to many people. IFS Cloud, we look at the trends of digital transformation and digitalization of operations, and we would like to summarize, let's say, our activities and our vision as follows. Just a flavor, because, you know, as I said, digital transformation means many things to many people. Sometimes people talk about applying mobility to the workforce. But of course, when we apply mobility to the workforce, not only do we want to create apps for people to execute, but we also want to provide augmented and mixed reality so that remote employees or experts that sit in an office or even at home can participate in the activities of the technician that is on site. Internet of Things was already mentioned. Automation was mentioned, how we automate the creation of prescriptive maintenance, you know, through the data that we have acquired. Simulation and optimization, how we can optimize the best place in the work schedule to execute the prescriptive orders. Digital twins as a digital representation with data and visualization. And the last one, contextual intelligence, which is, you know, actually the application of all knowledge that we have of assets and place that into context of the asset hierarchy. All of it in function of creating and maturing the asset performance management. And, you know, as a citizen, I would say our achievement zero carbon and reducing waste of any kind. So that was a quick insight in the IFS Cloud platform. Let's go back to our strategic objectives. So we mentioned, you know, that the challenges in the industry for utilities and renewables are market-based, finance-based, societal-based, but many of them are asset-based. Look at aging infrastructure on the delivery side, diversified assets in all the investments that we would need to do, achieving net zero to help clients move to more sustainable uses of energy, integration of new technologies. We saw the digital transformation, the APM, and the availability to manage the ability to manage the available data. In the end, when I summarize it, it's all about the assets. So, in summary, what would be the uniqueness or the unique capabilities of IFS Cloud to address, this concept of optimizing assets in the renewable business? First of all, it's about resource optimization. Unfortunately, nobody has unlimited resources, so we have to make choices. We have to make choices on how to invest and when to invest. And once we execute, we have to make choices about what to do and when to do. And the resource optimization service in IFS Cloud is there to achieve that. The full asset lifecycle is a great differentiator of the IFS Cloud when we apply it for EAM processes. He mentioned that the asset design phase determines 80% of the total lifecycle cost. So not including the asset design phase is missing out on this optimization before we even start operating an asset. Integration and analytics. It goes without saying that every company has already an incumbent IT infrastructure or an IT ecosystem that includes finance and ERP. IFS Cloud does not aim to simply replace all the IT infrastructure. We would really like to focus on asset lifecycle management and asset performance management, project performance management as the capabilities that we compose for your business needs while you leave your financial backbone in place, and we integrate through our integration capabilities and our open architecture. And lastly, the supply chain. The historic background of IFS as in the ERP, Enterprise Resource Planning, has given us a tremendous advantage over other EAM vendors in how we deal with supply chain for spare parts, supply chain for assets, supply chain for services, supply chain for transferring goods from one location to another, and to integrate vendors, contractors, in-house technicians with their resources, with their spare parts, with their replacement assets in the prescriptive orders and in the preventive orders, and hopefully not too many reactive orders that we need to execute upon. So, takeaways. Why would you choose IFS for EAM or asset management in the renewable space? First of all, our industry focus. We know the renewables industry through large numbers of customers on the delivery side, power generation side. We are aware of the needs of your industry, and we provide unique capabilities to deliver on your needs in your industry. Secondly, we deliver on all critical functions of the asset lifecycle management, not simply on the operate and maintain phases. So all the way from the project inception to the decommissioning of the asset, your assets are in good hands in IFS Cloud. AI-powered real-time workforce planning and scheduling optimization. And when we apply that to our EAM processes and EAM transactions, you will really see and reap the benefits of IFS Cloud. We will ensure that business transformation delivers value, not simply a product. We stated during this presentation that we want to align whatever it is that we do on the asset management side with your strategic objectives, such as revenue, such as margin, such as capital use, digital transformation, and the achievement of, let's say, carbon reduction or CO2 emission reduction. Those are the value drivers that we want to help you achieve. And lastly, we want to enable your industry and the asset owners therein to achieve their goals with world-class asset management capabilities that are underpinned and implemented by IFS Cloud EAM. So please reach out to us and join us on our journey to sustainable asset lifecycle performance and have that journey together with us. Thank you for listening to this webinar, and see you next time.